Good morning, PyCon. My name, once again, is Joram, and I came all the way from the cornfields of Iowa to come and give my first ever conference talk. And I am so glad that my first rodeo is happening at PyCon. So, from the few words that I've just shared with you, you can tell that I am not American. Why? Because I don't sound American. I've got a different accent. And that is at the core of what I'm going to be talking to you about today. Do not write Polars code with a Pandas accent. So why might you be interested in listening to me? As I said, I have a master's degree from the University of Illinois, and I studied information management, and the focus there was in data analysis and data science. I have also used Polars since 2023. I have used it in production. And lastly, but by no means the least, I am an author of a new book called Deep Analysis with Polars. So here's an outline that I'm going to share with you before I start. The first one is that I am going to share with you 5 Pandas accented mistakes that I have seen a lot of people migrating from Pandas to Polars make. And then I am going to show alternative idiomatic Polars code to correct those mistakes. And then I'm going to give you a recap of what I will have talked about. And finally, I am going to welcome your questions. Does that sound good? All right. All right. So first things first, what is Polars? It turns out that it is a bear. I am joking, but I am also not joking. But on a serious note, Polars is an open source library for data analysis and data manipulation. And you can think of it like Pandas, except it has a typed API and it uses expressions. I am going to show you what I mean by expressions with a few sample code. So Pandas accented mistake number 1, choosing columns with square bracket notation. I have seen this a lot, and it kind of annoys me. It works, but it annoys me. Here's what it looks like. So here, I am importing Polars the conventional way, import Polars as PL, and then I'm reading a data set. It is a Parquet file, and this is a data set about liquor sales in Iowa. And here, I am interested in selecting the 3 columns, which are date, store, and pack. And the way I am selecting them, I am using the square bracket notation. This is a Pandas relic. A lot of people make this mistake, but the idiomatic way to do it is actually to use the select method. Now, here's one way to do it, which is good, but I think it is overkill. So I am selecting the columns here as expressions. So pl.co date, pl.co store, pl.co pack. I am selecting the columns that I need from the data frame, but this is overkill. The good way to do it, I think, is just to mention the column names. So in this line of code that is not grayed out, I am simply mentioning the column names and then selecting them. So why might you be interested in doing it the other way, though? The way I do it is when I am modifying the column. So whenever you are making a change to the column that you are selecting, then you can select the column as an expression. So in this case, I am targeting the date column, but I'm interested in extracting the month value out of that. So I'm going to select the date column as an expression and then extract the month value, and then the rest of the columns, I am going to select them just the way they appear on the data frame because I am not modifying those columns. So this is the final data frame that I would get. Pandas accented mistake number 2, using multiple intermediate variables. Pandas people love their intermediate variables. However, in Polars, I think you have to let go somehow of intermediate variables and try to chain your operations. So here is an example of a question that we might be interested in tackling. Which category out of the liquor categories generates the most revenue, and does that ranking change when instead of considering the revenue, we consider the volume of the liquor? So the Pandas way to do it, or the Pandas accented way to do it, not the Pandas way, but the Pandas accented way, is to create a variable called revenue ranking. And then we're going to load our data frame and then create a new column called revenue, which is going to be a calculated column. We are calculating the bottle sold times the retail price to get that revenue. And then we're going to group by. So group by the category to get the aggregation on the revenue, so the sum aggregation on the revenue, and then we're going to sort the revenue in descending order. Once we have that, so that the highest revenue is at the top, we can create an index to have that ranking. Now, the index in polars starts on 0. To make that start on 1, because the ranking makes sense when it starts at 1, we can offset that and then change the default column name index to revenue rank. So we have that. We have created that data frame. This is the data frame that we have. So when I look at this data frame, I see that American vodka is ranked number 1, followed by Canadian whiskeys and so on and so forth. Then the second step is to create another variable, which we're going to call volume ranking. And we're pretty much going to do the same thing, right? We get the data frame, we group by the category, and then we perform an aggregation on the volume in gallons, and then we sort that summation in descending order, and then we create the ranking. So this is what we get when we rank these categories in volume. Then finally, we're going to combine those data frames to get the answer that we actually need. And in joining this, we're going to join using the inner join. Turns out that in polars, when you perform a join and you don't specify the type of join, the default join that you get is the inner join. So here, we're joining on the category because that is the column that is present in both of our two data frames. And then we're going to this is an important step. We're going to change the data type of the rank columns, because if we look at the initial data types here, we see that they're all in unsigned integer 32. Unsigned integer 32, so we have to turn them into integer 32. And the reason why we're doing that is to prevent integer overflow when we do this subtraction in the next step. So once again, we're going to do the subtraction on revenue rank minus volume rank, and then sort the data frame on the revenue rank, and then select the final data frames, the final columns that we want. So this final data frame, though, if we look at it, what does it tell us? It tells us that American vodkas does not change in the ranking, whether we consider the revenue or we consider the volume. However, if we look at a category like triple sec here, this line, we see that this one changes. So initially, its ranking was at 40, but when we changed the ranking using the volume, it actually moved up 16 points. So now it is at 24. So this is this is the data frame that answers the question that we set out on answering. So the idiomatic way now to do all those stages that we computed is actually to do it in a single chain of code. And this one, I think, is some beautiful code. So we can say dot with columns to create the revenue column, and then we do that multiplication. But look at this. It actually turns out that there's this method .mul, which is the multiplication method. So we can use that and then group by the category and then do the sum. Here I am doing the sum, the aggregation sum, on 2 columns at once. Why do it one by one when I can do it at once, right? So once again, I'm also creating the revenue rank and the volume rank. And then instead of creating an index to get the ranking, I'm actually going to use an expression called rank, and then the method of ranking that I want to use, which is the ordinal ranking, because I want that to be in order. And then I'm going to do the descending is equal to true, so that I want the highest to be at the top, to be ranked number 1, and then do the same for volume ranking, and then do that subtraction here. But once again, I'm going to be careful. I'm going to change the data type from unsigned integer 32 to signed, from unsigned integer 32 to an integer 32, so that I can prevent that problem of integer overflow. And then I can do the sorting here and select the columns that I want. It looks like a lot of code, but as Matt Harrison always says, you don't build this chain of operation at once. You build it in stages. So it is very easy to actually build it than just looking at it and thinking, how was he able to write all those lines of code all at once? I did not write this at once. I was doing it in stages. So the things that I've just shared with you about chaining your operations and actually using intermediate variables can be summarized with a metaphor about your teenage daughter. So suppose you're sitting in the living room with your teenage daughter, and you tell her to go to the kitchen to go and get you some salt. So she goes to the kitchen, brings you the salt, and then as soon as she hands you the salt, you say, now go back again to the kitchen and get me a glass of water. So she goes back again to the kitchen and brings you that glass of water. But before she hands it to you, she picks up the salt on the table and looks at you with a frown on her face and say, do you know that I can carry both salt and a glass of water all at once? In other words, you wasted your time sending her to the kitchen on multiple trips when one trip would have sufficed. That is how I imagine Polars feeling every time you create unnecessary intermediate variables. It is screaming in your face and saying, I can do all this at once. Why do you want me to do it one by one? So if you can avoid it, never use intermediate variables. Try to chain your operations so that you can get the benefits. Now, if the imaginary screaming of Polars don't convince you, maybe speed can convince you. It turns out that when we run the computation comparison between the one that uses intermediate variables and the one that uses a chained operation, this is the speed that we get. Intermediate variables, 31.3 milliseconds. Idiomatic chained operation, 17.3 milliseconds. So once again, if you can, try to avoid using intermediate variables. Pandas accented mistake number 3, the overuse of eager execution. What do I mean by that? Well, eager mode, which is the normal way that a lot of people run their computation, you get the results immediately. But when you do it, the lazy mode, the computations are actually collected into a lazy frame, and then the query plan tries to optimize your computations and then gives you the results. Now, the way to do that, the way the query plan actually does that is by using operation techniques such as predicate pushdown. What is that? That is just a fancy way of saying, let us filter out the columns, or let us filter out the rows that are not necessary before we do the computation, because doing a computation on fewer rows is actually a lot more performant. And then another technique is called projection pushdown. Now that is just selecting the columns that are needed earlier before actually wasting time on all the computations. So how does this look like? Let's consider answering the question, show the categories with a change in ranking greater than 10. So from the data frame that we had previously, I think G17, maybe not. All right, so I think I can do. Yeah, based on this data frame, what we want to find is what are the categories that had this change in rank greater than 10. So we don't care either up or down, but it has to be greater than 10. All right. So this is the same code here, but in order to turn this piece of code into a lazy frame, we have to use the lazy method first. So we get the data frame and then use the lazy method. When I do that, I actually turn the data frame into a lazy frame. And if I want to get the results of that lazy frame, I have to call this collect method. So this is what is happening here. But the line of code that we introduced here is the filter. So I'm doing a filter here, and I'm using the absolute expression to get the change either positive or negative. Now, what is going on here? Let's do a performance comparison. If I run that piece of code in eager mode, I get, it runs in 17.6 milliseconds. If I do it in lazy mode, it runs in 16 milliseconds. So not that big a deal, but it actually, it makes a difference when you have a lot more rows. So what is going on in the query plan that we talked about? The way to read this actually is to read it from bottom to top. So if I look at these stages here, I have the table, but actually the ones that I want you to focus on are these. So let's take a look at this. I have the filter happening before the sorting. However, if I look at my code here, I have the filter happening after the sorting. So what happened here? Polars was clever enough to realize that it is a lot more performant to do the filtering first and then have fewer rows and then sort those rows, as opposed to sorting the many rows and then doing the filtering later. So this is the query plan at work here, if we look at it, right? The filtering is happening after or before the sorting. So this is what we mean when we say try to use lazy evaluation if you can, because you can get the performance benefits that come from the query plan as well. Okay, so number 4, Pandas extended mistake number 4, adding columns horizontally. This is a bit tricky because a lot more people don't know that there's an expression that actually does this in polars. So if we look at this data frame, we have the store, and then we have the month, and we have the days, Monday through Friday. Now, suppose I wanted to do a summation of the values in Monday and Friday, so across the data frame. The non-idiomatic way to do it is to actually add these columns one by one. So I have the column for Monday, I have the column for Tuesday, all the way to Friday. I think this is a bit tedious. The slightly idiomatic way to do it is to use the index selection. So I can say, hey, let me use the polars expression here and say sum horizontal, and then I'm going to pick the columns that I'm interested in summing. So in this case, we're interested in summing the column that appears on the index 2 all the way to 6. Now, if you think about this, if you have a lot more columns and you have to list all the numbers, 2, 3, all the way maybe to 100, that would be tedious as well. So we can employ the range function that Python offers us and do that to actually prevent ourselves from doing all that. But this is also not idiomatic. The idiomatic way, in my opinion, to do it is to actually do it like this. Sum horizontal PL.O. This means I am selecting all the columns, and then I'm excluding the ones that I don't want to add. So the store and the month, I don't want to add those. So I'm going to exclude those. And when I run that, it turns out that it gives us the same result. So if you look at these columns, the total columns that I have created, they all have the same values. So all these methods work, but I think the idiomatic way is this one. It turns out that we can even turn this to be even more idiomatic by using polar selectors. Now these, I think they are the unsung heroes of polars. A lot more people don't use them, but they are very important, and I think from now on you should start using them. So here, I am employing the polar selectors, and if we take a look at this line here, the line number 4, where I am creating the total column, I am saying PL.sum horizontal, and then CS, which is polar selector, and then I'm only interested in selecting the columns that are float columns. So they are the ones that I want to add. So when I do that, it actually does that selection automatically, and I can select the rest of the columns that I want to see. And finally, since this total column was actually created beginning with an underscore, I can say cs.starts with underscore, and then I can pick that alone and have this data frame. So polar selectors, let us start using them. Let's make them heroes. Last Pandas accented mistake, don't use drop. A lot of people coming from Pandas love their drop. They want to drop a column, they use drop. I feel like this is the wrong way to exclude columns. What you want to do, actually, suppose I wanted to drop the column store here. What do I need to do? Well, if I'm not using drop, first, I can do it the drop way. So when I do that, this works. However, when I try to drop a column that does not exist in the data frame, it turns out that this does not work. Your code breaks. However, if I do it the idiomatic way by using PL.select, I can select, or I can exclude the column, and even if it doesn't appear in the data frame, it still works. So in this case, I exclude the store column, and it disappears. I try to exclude the column that is named after me, Joram. It does not appear in the data frame, and yet the code runs. So it doesn't care whether the column appears or does not appear. And that is how that works. Now, a recap. So what did we talk about? We talked about thinking in polars first, not in pandas. A lot of people try to get their pandas code and translate it almost literally to polars. Don't do that. Think in polars first. Think in expressions. Number 2, leverage the query optimizer. And to do that is to use the lazy mode. And if you want to squeeze even more precious drops out of the query optimizer, you should chain your operations and avoid intermediate variables. And finally, just never use drop. Just never use it. use exclude instead, because that will save you a lot of headaches. So pop quiz, now that we have learned how to write idiomatic Polars code, I am going to show you a piece of code, and you're going to tell me whether it is Pandas accented or idiomatic. So is this code Pandas accented or idiomatic? Let us look at this piece of code. Is it Polars, idiomatic Polars, or Pandas accented? What do we think? Pandas accented? That is right. It is Pandas accented. What about this piece of... so the idiomatic way to write this is actually to use the property height. So instead of getting the shape of the data frame, that will give you the height and the number of columns, you can actually use the height to just get the height of the data frame. What about this one? Pandas accented or idiomatic? Pandas accented. Why is that? Yes, it is Pandas accented, but why is that? Square bracket notation. That is good. Yes, you have learned something. The idiomatic way to do it is actually to use the method getColumn. So this is special, actually. The reason why we're doing this, the reason why we did not use .select here is because when we use select, we actually get a data frame. But when we use getColumn, we get a series. And this method, the value counts, only works on series. So this one was a bit tricky. The last one, Pandas accented or idiomatic. This is a lot of code, but I want you to focus on these lines of code, the ungraded ones. Is everything okay, or is there something amiss with these lines of code? This is tricky. Idiomatic, right? Who says idiomatic? Who says Pandas accented? It is actually Pandas accented. And the reason is that these square brackets on the .select method are unnecessary. The idiomatic way to do it is just this. You don't need those square brackets. And finally, I am happy to take your questions.